Hello Econ 200. In this video I'm going to go over homework problems from the Chapter 11 homework set. There's going to be 3 problems that I go over in this video. I'm going to post a second video on a 4th problem that requires me to use, or will be easiest for me to use, Panopto, so I can show you my screen, an Excel spreadsheet. So for this, let's go over the following problems. The first one is going to be Facts and Tools, problem 10. And the wording of the problem says the following. The chapter pointed out that whenever money is used to purchase capital, interest costs are incurred. Sometimes those costs are explicit, like when Alex borrowed the money from the bank. And sometimes those costs are implicit, like when Tyler had to forego the interest he could have earned had he left his funds in a savings account. If an economist and accountant calculated Alex and Tyler's costs, for whom would they have identical numbers and for whom would the numbers differ? All right, so let's take a look. Now this is making a reference to an earlier part in the textbook in Chapter 11. If you go to Chapter 11 and you go to page 198, page 198, the second paragraph begins as follows. Imagine that Alex and Tyler, who incidentally those are the first names of the textbook authors, suppose that they each decide to drill an oil well in their backyard, which costs $200,000. Alex borrows the $200,000 from a bank at a 5% annual rate of interest, so Alex must pay the bank $10,000 per year. That's going to go in this column. The interest payment would be $10,000 per year. Tyler pays the $200,000 out of a small inheritance he received from a rich uncle. Each well produces $15,000 worth of oil annually. Which well is more profitable? So interest payment, you're told that Tyler, he pays for the $200,000 cost of drilling the well out of money he already has. Okay, it's an inheritance that he received. So he has no money for his interest payment. Let me see. Then we're told each well produces $15,000 worth of oil annually. So we'll put those numbers into the revenue column. That's the same for each of them. All right. Then it says, at the end of every year, Alex pockets $5,000, which is the $15,000 in revenue, minus the $10,000 interest cost. So his accounting profit is $5,000. While Tyler pockets $15,000. It's tempting to conclude that Tyler's well is more profitable, but that would be a mistake. Tyler could have left his $200,000 in the bank, and at a 5% rate of interest, he would have earned $10,000 a year in income. So that interest opportunity cost, if he had taken his $200,000, put it into a bank account and earned 5% per year, that would have been $10,000. So notice he has the same cost of capital as Alex does. It's just that Alex is having to pay that money out of his own pocket. For Tyler, the $10,000 is an opportunity cost. It's $10,000 a year that he's giving up receiving from the bank because he put the money into drilling his oil well. Okay, so Tyler's opportunity cost is the $10,000 in income he gave up. Thus, once we take into account all costs, including opportunity costs, Alex and Tyler's are equally profitable. Their drilling operations are equally profitable because Alex does not have that interest opportunity cost. He had to borrow that money. He didn't have the money to loan out. Okay, so the accounting profit is going to be different for these two individuals, but the economic profit is the same. Take the accounting profit of $5,000, subtract out the opportunity cost of 0. Alex is making $5,000 in economic profit. Tyler has accounting profits of $15,000, but when you subtract out his opportunity cost of what else he could have done with his $200,000 inheritance, he also has economic profits of $5,000. Now, the problem asks you, problem 10 in this chapter asks you, who would the accountant and the, what would you say? Who would the accountant and the economist have the same numbers for? Who would they both agree has the same costs? Well, that's going to be for Alex. Both the accountant and the economist would be subtracting $10,000 of interest from Alex's revenue and coming up with the economic or accounting profit of $5,000 each. For whom would it be different? It's going to be different for Tyler. The accountant takes his $15,000 of revenue and doesn't subtract anything from it, okay? Whereas the economist takes the $15,000 of revenue and subtracts a different cost of $10,000 in opportunity cost and finds a different economic profit than the accounting profit, okay? So that is the answer to problem 10 in Facts and Tools. Let's move on to thinking and problem solving. We're going to look at problem 7 first. And problem 7, this was the one that most people needed help on, okay? And it's also the one that during office hours, quite a few students asked me to cover this. So it runs as follows. You run a small firm. 2 management consultants are offering you advice. The first says that your firm is losing money on every unit that you produce. Spoiler alert, it's going to turn out that actually, in order for this answer to make sense, your firm is losing money on average on every unit that you produce. It doesn't have to be that each unit you sell, you're selling at a loss. To reduce your losses, the consultant recommends that you cut back production. The second consultant says that if your firm sells another unit, the price will more than cover your increase in costs. In order to reduce losses, the second consultant recommends that you should increase production. 2 parts to this problem. Part A, as an economist, can you explain why both facts that the consultants rely on could be true? Okay, there's 2 facts that you're told, and we're going to cover them one at a time. I'm going to graph how each of them could be true one at a time. So start with the first consultant. The first consultant says that your firm is losing money on every unit that you produce. Again, we're going to treat that as you're losing money on average. In order for that to be true, it needs to be true that the price that you can sell at, your marginal revenue, must be less than your average total cost. Okay? So let's draw that. There's your firm's average total cost. Marginal revenue is just a straight line. And we'll set it, put it right here. So that's the price that you can charge, which is also your marginal revenue curve because this is the chapter on perfect competition. Okay. So if this were the case, it would, no matter how many units you're producing, the price that you receive per unit is going to be less than your average total cost of producing that many units. So you're losing money on average on every unit that you sell. Okay, so far so good. So the first fact is taken care of. Second fact, the second consultant tells you that if your firm sells another unit, the price will more than cover your increase in costs. So for this, we need to think about marginal cost. Marginal cost curve, we're going to draw as a U-shaped curve, and it's going to hit the average total cost curve at its minimum. Looks like I slightly missed that, but should go through the minimum of the average total cost curve. There's marginal cost. Okay, so this guy is telling you if you produce 1 and more unit, the price that you can sell it at is going to be more than the marginal cost of selling that unit. Where is that true? Well, that can't be true to the right of this point. Marginal cost is above marginal revenue. Can't be true to the left of this point because, again, marginal cost is above marginal revenue. The only range where that can be true is in this range of the graph right here. Marginal revenue is greater than marginal cost in this part of the graph. So we're going to need to make it to the left of this point where marginal cost equals marginal revenue. Pick any point along here. That's the quantity of units, okay? Could have drawn it here, could have drawn it there. I'll just pick that point right there. So the first consultant is right. If you produce that level of output, your average total cost is greater than your marginal revenue, and so you're actually making a loss by selling that number of units. However, the second consultant is also right that if you produce output, if you increase output on those next units you produce, you're earning more than what it's costing you to produce them. Okay? So that brings us to part B. Which consultant is offering the correct advice? Going to turn out to be the second consultant. Remember that you should be producing where marginal cost equals marginal revenue. Right? That's your Q star, your best level of output. So it might still be true that you're losing money on average on every unit that you produce at this quantity, but you're going to have a smaller smaller economic loss by operating at this level than operating at a lower level of output. Okay, so part B, the second consultant is correct. You want to produce here where marginal cost equals marginal revenue and marginal cost is increasing. Okay, and that brings us to problem 15. I am also, in thinking and problem solving, I am going to go over problem number 9, but again, that's going to be in a separate video. Okay, question 15 says the following. Look carefully at figure 11.6. What is represented by the space in between the average cost and average variable cost curves? Why do they get closer together as quantity increases, and will they ever meet? All right, now what they are calling average cost, remember that I have been referring to as average total cost. Let's go to that page. Oops. Having some trouble here. There we go. So here is figure 11.6. Let me straighten that out for you. There is the average cost curve or the average total cost curve. There is the average variable cost curve. Okay? The distance between these two curves, that is always going to tell you the average fixed cost. Because remember, the average total cost of production is simply equal to the average variable cost plus the average fixed cost. And so the distance between those two curves will always be the average fixed cost. Will they ever touch? No, they never will meet. They'll get arbitrarily close together, but they will never meet. Why is that? Well, it's because you're dividing, your average fixed costs will never go down to zero. Let's say you have $1 million in fixed costs. If you produce 1 unit, your average fixed costs are $1 million. You divide the million by 1. Okay, well, there would be $1 million between those two curves at that point. Suppose that you produce 2 units, then your average fixed costs are $1 million divided by 2, which is $500,000. So at the second point, these two curves are going to be $500,000 apart from each other, but still they're not touching. What if you produced 1 million units? Well, then you have $1 million fixed cost divided by 1 million units. That's $1 in average fixed cost per unit. So you're getting closer, okay, but you're not getting, they're not touching each other. What if you produced 100 million units? Well, now your average fixed cost would be 1 penny per unit. A lot closer, but still not exactly touching. If you produced 1 billion units, well, then your average fixed cost would be 1/10 of a penny per unit. But as long as your fixed costs are a positive number, you can keep dividing it by a bigger and bigger and bigger number, and it will never go to exactly 0. It'll get closer and closer to 0. It gets arbitrarily small, but it never gets to 0. And average fixed cost being 0, that's the only way that these two curves could touch each other. Okay, if there's 0 distance between them, they're touching each other. And for that to be true, average fixed cost have to be 0. That's never going to happen. So that's it for this video, guys. I'll post another video covering problem number 9 from Thinking and Problem Solving in Chapter 11 shortly.